Hello, everybody, and thank you for joining us today. My name is John Place. I work in marketing at Tulip, and I'll be the moderator for today's webinar, Machine Monitoring 101. So today we're going to take a really detailed look at the very basics of machine monitoring. I'm joined by some really fantastic guests today. So we have two partners from Clear Process Solutions who are experts in all things manufacturing and machine monitoring. So I want to turn it over to them and let them introduce themselves.
Hi, this is Rob Mangler. I'm from, as you say, Clear Process Solutions. I just want to start off by saying Happy Machine Monitoring Month. I'm based here in the Chicago area and looking forward to this discussion.
And hello from me, Chris Winters. I'm Clear Process Solutions Solution Engineer for the Tulip and Onshape platforms. I am regionally based in the Northeast Ohio area, but I am all over the country. I've been in manufacturing for about 15 years as a precision journeyman machinist. I'm also an ISO 9001-2015 certified lead auditor, and I'm looking forward to getting into what machine monitoring is and what it can do for you.
Right. Rob, would you mind telling me a little bit about Clear Process Solutions?
Sure. We're experts in digital process transformation. We're focused on workflow, data analytics, business process optimization. We simplify complex processes, complex data, and complex integrations. We're focused on ERP, PLM, MES, and CRM environments. And we help our clients clearly see and manage their processes and their data. And we help them make intelligent business decisions. The CPS team works with companies to improve manufacturing efficiency on their shop floor. Tulip, a CPS partner, thank you very much, is building technology that puts people back at the center of manufacturing. And that's why we're here today.
Excellent. We're really pleased to have you. And we've worked with Clear Process Solutions extensively, and they really walk the talk. They have been wonderful, and they really know what they're doing. So we're really pleased to have them with us, and we're really pleased to have these two particular speakers. So then on Tulip's end, we have Dylan. Would you like to introduce yourself?
Hey, yeah, my name is Dylan Forsese. I'm the head of application engineering here at Tulip. That ranges all sorts of things, connecting devices into Tulip like scales or torque drivers, ERP systems, SQL databases, and also, as it turns out, lots of machines worldwide.
Excellent. All right. Well, thank you all for being here. I'm really excited to get started and to start talking machine monitoring. Let's do it. All right, so let's kick off the webinar by opening this sort of big topic of what is machine monitoring. It's a phrase that gets thrown around a lot, and because all manufacturing operations are so different and because solutions are so different, it'd be really helpful to just sort of get a standardized definition or at least an introduction to sort of key concepts and do some FAQs. So Chris, do you want to talk about what machine monitoring is and like what it can do real quick?
Yeah, sure. Machine monitoring is basically the ability to view a machine operate under normal conditions. A couple of examples are if a turning or milling center is completing a program, cutting chips away from a part, a packaging machine completing its cycle, a filler putting product into containers on a production line. In the old times, what used to be used as machine monitoring was literally somebody running the machine and another person standing there with a stopwatch in their hand and clicking to see how long the cycle actually took to complete. One of the other things that machine monitoring nowadays does is it also allows you to see when the machine is down for changeover, if it's maintenance, tooling changes, for a variety of reasons. But overall, it's watching a machine operation from start to finish and also the times in between.
Yeah, excellent. And I think there are two really important things you brought up there, which is just like machine monitoring takes what was previously a manual method of collecting data, of having someone standing at a machine with a stopwatch and timing and putting operators under sort of a supervised condition, and it automates it. And it also gives you an objective measure of machine state. So there's no guessing whether a machine is up or down or idling. You have an objective readout of what's happening there. Dylan, I know you work with this extensively. Is there anything you want to add?
No, that was pretty good.
Excellent. Great. I love it. So when we talk about machine monitoring, there are a lot of different parameters. There are a lot of different ways you can take data from a machine. So like what exactly are you monitoring? What kind of things are manufacturers looking at? Dylan, you want to take that?
No, you're talking about what types of data they're trying to?
I think precisely. Yeah, let's go with that.
Sure. So yeah, I think that really depends on what type of machine you have, but also what you're trying to learn. So for example, we have lots of use cases that come kind of commonly, people want to understand basic OEEs. They want to know how long their machine is running or how long it's idle or off. We're able to discern that kind of information by, looking at things like part counters on the PLC, looking at things like the job name, time that it's running, time that it's off. Those are tags on the PLC that we can pull into Tulip.
Excellent. So it sounds like machine monitoring fits as sort of like a broader system of industrial data collection. Might be difficult to integrate. Chris, do you want to talk about integrating? And yeah, would you talk about integrations?
Integrations that CPS and Tulip have done have pretty much run the gamut now in today's current manufacturing operations. With companies with newer machineries, with HMIs, human-machine interfaces, where they actually have a control, there's a variety of software out there that you can actually use to interface with Tulip to pull those machine tags that Dylan was referencing, to be able to give us those types of analytics of uptime, downtime, reason codes, and a variety. Tulip and Clear Process Solutions have also gone out into the field and incorporated machine monitoring on older case machines for companies that have got machines from as early back as in the 1950s and 1960s, utilizing IoT devices to actually turn around and actually capture the machine monitoring that used to be done on a manual process or a manual counter by utilizing brake beams, capacitive sensors, and a wide variety of tools that can be connected to the Tulip gateway.
Yeah, that's super interesting. So it's not something that you really need the newest machines for. It's something that there are ways to hook up older machines, legacy machines.
Yeah, absolutely. I mean, any machine can be monitored. If we can speak to it over a protocol, if we can plug into a port, we can read it that way. If not, we can add sensors. If we're not able to get all the data we want directly from the PLC or the HMI, we can add sensors and do a combination of both. It's really a very flexible system because of the amount of no-code customability in Tulip.
So, yeah, just to follow up on that point, I know one question we get early on in conversations with customers is whether or not machine monitoring will communicate with specific protocols, whether they're older or sort of niche and specific. Is that ever an issue?
Yeah, certainly. There are some protocols that were developed, quite a long time ago that aren't very well supported. Good thing there are a lot of companies, making all of their money by basically just being an interpreter for all of those protocols. One of the major players right now, there are really a few, but OPC UA and MT Connect are two of the biggest ones. Tulip's able to natively speak both of those. And then for other things, we leverage software like Kepware, which specializes in just having plugins that can connect to older machine protocols.
Excellent. So just to continue on that, how difficult would you say it is to get started, like with all this industrial technology? Chris, do you want to speak to that? Like how, when manufacturers are looking at getting started with machine monitoring, what kind of timeline is there, and are there considerations?
Well, the considerations usually that I point towards from the first phone call in is have they looked inside their internal operations and determined what key performance indicators are looking to get from machine monitoring and what value it is to their company. We can get all sorts of data, but data that's valued by the company for what they need to be able to see to improve operations is usually a good starting place. As far as starting and getting it implemented, it's as easy as going to Tulip's website or to Clear Process Solutions website and requesting more information and reaching out. We actually come in and we'll come in on site and we'll take a look at the machinery and we'll start the conversation right then and there. Usually from first conversation to implementation has gone anywhere from 7 weeks to 2.5 months usually at the longest.
Yeah, and we have pretty close relationships now with lots of machine manufacturers. So even just a quick phone call, oh, I have this Sugami XYZ, we're able to, we have an internal kind of database of the machines that we've already connected to. Chances are we've probably spoken to that machine or like a close cousin of it, and we already have insight into how to get that online and get information into Tulip pretty quickly.
Excellent. Yeah. So in our experience too, just working with customers, it's something that can get up and running fairly quickly. And I'm definitely going to come back to this because the whole topic of how do you get started is something I want to cover in more detail. But really quick, Rob, I wanted to ask you, so who is machine monitoring useful for? Like, is it something that's just going to be useful for the engineers, or is it something that operators and management are going to care about as well?
I think the short and easy answer is yes. It's useful for everyone. Engineers, operators, management, they all need and have been dying for the information that these machines are cranking out. This kind of data is essentially more oftentimes lost or just inefficiently retrieved and very frequently not up to date. So what Tulip allows is for all of this information to be accessible to virtually everyone requiring it in real time. And that's huge for just about every organization with a machine.
Excellent. Yeah. Excellent. Excellent. All right, that was a great opening. We covered, I think, everything we needed to cover to introduce everyone to machine monitoring. So I think at this point, I want to move the conversation toward getting started and what actually designing a first use case for machine monitoring and designing a machine monitoring solution that works in very specific local conditions looks like. So I know, Chris, you've worked in manufacturing for your whole career, and now you help manufacturers design those solutions. So when you're working with a customer for the first time, how do you go about helping them sort of scope and think about how machine monitoring will work for them?
Usually the discussion starts with someone from the C-level of operations, the plant floor operations, engineering, and quality. Usually it's not a super duper long meeting. It usually takes about 45 minutes to an hour. And part of that is actually with the initial conversation, what they initially brought to the table for their concerns. And then we actually go a little bit deeper and we start going into what their real true pain points are. You know, is it idle machines? Is it inefficient workflow? Are they having a problem with on-time delivery? You know, are they really truly being able, what insight do they have to their floor operations right now? How many times are they twice, thrice handling data? You know, what failure modes are actually happening on the floor right now that they'd like to be able to close the gap on? And have a real honest discussion with the mid to upper level management before we actually go out onto the floor to be able to see and help them develop what key performance indicators they are looking for if they don't have an idea. I mean, everybody wants to be able to make their operations faster, more efficient, and cost effective. A lot of the times, machine monitoring mixed in with a couple of other solutions can give a rapid ROI turnaround to prove the value of what they actually want to do for their next steps and give them insight into future iterations of Tulip out on their shop floor to give them even better metrics and better throughput.
Yeah, that's excellent. And I think that resonates a lot with kinds of conversations I've heard from engineers at Tulip, which is just there isn't necessarily a one-size-fits-all solution, and the amount of information you can put in before you start trying to design a machine monitoring solution will only help inform what you come up with and will only help you design something that actually proves ROI and makes a more significant impact in the long run. So then, in your experience from sort of initial conversations to running on the shop floor, what does that timeline look like?
If their internal operations are in line and their purchasing department and IT department are online, we can go like I said, as anywhere from as fast as 5 to 6 weeks to 2.5 months has been the longest stretch. And that actually, the only reason why I was at 2.5 months was because there was a delay in the purchasing of certain IoT devices that we wanted to have connected to the machines.
Excellent. So in terms of just like industrial technology, that's an incredibly fast timeline.
Well, that's the beauty of working with Tulip, and the fact that it's a no-code platform, and that if you wanted to be able to integrate with your other business systems, there's a little bit of coding, but being able to turn around and connect with REST APIs and SQL databases for the company's ongoing operations through their MES and ERP systems, being able to pull certain data from that, as well as being connected to the machine monitoring, it's not a world where it's heavy code laden anymore. The strength of Tulip's platform is the fact that it is no code to build the apps. It's no code to be able to pull the analytics. And a great starting point for it is if anybody's ever worked in a basic Excel spreadsheet and a basic PowerPoint presentation, they're about 60% of the way there, being able to develop the apps and be able to turn around and pull their analytics on their own.
Yeah, absolutely. And just to add to that point, the code that you're talking about would be the direct integration to their business system. So if they have an API, we write a single function that will say, for example, when a job is done, it just pushes the final work order information into that system. Once you've created that function once, you can then call it from any application in a no-code way. So there's an initial setup of making those connections, then they become basically no-code blocks that you can use in any Tulip application.
Yeah, the whole idea when we come into operations, companies will always still need to get parts put out on the floor. One of the beauties of the deployment of Tulip is that it doesn't interrupt your operations. It can be seamlessly integrated into your day-to-day operations without any major disruptions in your product flow as it's running currently. And then as you're gathering that data and looking at what you're getting for feedback, you're able to do adjustments and see that real-time data to make sure you're moving in the right direction for process improvement. And it's not stopping or shutting down your floor for a day, a week, a month, a year. We come in, and when we do the deployments, the machines have already been hooked up. They're still running. We go through usually between the beginning of shift and the first coffee cup break. We have the operators on the floor trained to be able to work with the interface. Then we review for until lunch. And then from lunch for the rest of the day, we're working with the engineers to show them how we built those initial apps and how they can build and improve upon them.
Excellent. Yeah, that's a pretty quick onboarding when you're talking about a new piece of software, to be able to go in a day to having it deployed and used, to having engineers able to then produce and iterate on those applications.
Yeah, I think a big mission statement of Tulip is we want to empower process engineers and people on the floor to build their own applications and find their own solutions. You don't need to be beholden to, large kind of manufacturing consultancies who are going to build these very rigid applications for you. And so the platform has been designed from the bottom up to be as, user-friendly and familiar to people who, have experience with basic BI apps like, as you said, Excel and PowerPoint.
Yeah, I mean, when you're working on a shop floor and you've got your machine monitoring hooked up to, we'll just say a two-axis turning center. And we've got that running. In the afternoon, we would turn around, and if they have the machine monitoring software hooked up to a mill, we can actually make a copy of the turning application, and with a few minor changes to the process, be able to collect all the KPIs off of that milling center as well. The days of IT heavy code driven processes and software are gone. And I mean, it should be allowing to let those people in the shop who know the process be able to turn around and give their input and be able to see that input in the applications themselves.
Yeah, I think, to sort of second everything that's going on here, is that is sort of the mission statement of Tulip, is to avoid those costly repeated professional services and integrations, to be able to give those people who are involved in the processes day to day the opportunity to then make changes as necessary without disrupting anything. And so, Chris, I want to follow on something you just said. You just brought up an example of a mill, and it made me think that not all machines are mills, and not all people who are running mills are going to be interested in looking at the exact same kinds of parameters. So I wanted to open this up and talk about how you guys think about designing use cases and what kind of parameters you and the customers you work with are measuring.
Well, usually one of the big first ones is uptime and downtime. I mean, that's a very basic machine monitoring. It's one of those things that we like to call low-hanging fruit. The key performance indicator that we add on to that, though, is downtime reason codes. So when the mill is down for X amount of seconds, or if it's down for more than 2 minutes, whatever your load time is for the next part, it would actually bring up a reason code screen, and the operator then interacts with the application, selects the reason code, and then that gets stored in the data. What that allows is for the process engineers to turn around and see that 3/4 of the way through the shift on a consistent basis, they're waiting on material to be coming from the warehouse. or there's a 20-minute tool change over every 10 pieces. And they can actually turn around and look at where the strength of their process is at and where the weak points are. And when they know what the weak points are, they can actually start taking a look at seeing how they can close those gaps and improve overall equipment efficiency. As well as with Tulip, it's not just OEE, it's OPE, because you're actually gathering that human element and capturing what's going on with the operator as well, not just the machine. Another great use case was going through for cycle count machinery. For middle volume cycle counting is always, once again, seeing downtime waiting for materials. If they have to restock certain cartridges on the machine, where those cycle counts and how they can actually turn around and tweak the machine monitoring outputs, and being able to see where they can maximize. If they're changing out cartridge 1 every 200 pieces and cartridge 3 every 400 pieces, maybe they could do a tooling change to where they're both in the same time so the downtime isn't being broken up as much. Or if they wanted to incorporate it through Tulip, they can send SMS or text messages to their warehousing department when the piece count hits a certain part to know that they need to bring over more stock. If they do have a downtime reason for any length of time and the machine is actually down, you can automatically send a message to their supervisor so the supervisor knows, hey, the turning center, 345 has been down for 10 minutes, no activity is going on, you might want to take a look at that. And that can happen through email and text messages, so the operator is able to actually stay at the machine more of the time. There's a whole bunch of different metrics, but usually uptime, downtime is a really great starting point for that. And we usually build off of that to be able to give value added to the customer and give them insight to where they previously didn't have any whatsoever.
Yeah, I think that's a really important observation, that like while everybody's operations might be different, this sort of one metric can go really far in revealing other problems that might be lurking beneath the surface. I guess that sort of simple objective visibility that when you start taking in things as they actually are, it requires you to actually ask more questions. You're not just asking what's uptime and downtime, but when you know that it's X percentage up, you can ask, okay, I'm not happy with that number. Why precisely is that?
Right. Yeah, machine monitoring is the gateway to a lot of other pieces of low-hanging fruit.
So yeah, Dylan, any other use cases you can think of that?
That's a very good starting point. Sometimes we'll have customers come to us with a really specific thing that they've already identified as a problem. So maybe they brought the stopwatches out, or they're seeing somewhere down along the line in their quality check that they're seeing a very specific issue and they want to monitor for that. And then they already know, if we reduce this thing by this percentage, they recognize the ROI of that. And so we'll set it up specifically for them. But I would say if a customer comes to us and they say, which happens very often, is, we know machine monitoring is a very big thing now. We recognize that it's important to have in our factory, but we still don't exactly know why, other than uptime, downtime. We say, okay, here's a great place to start. As Chris and Rob said,
I also did want to touch back about when we were first doing the introductions and talking about what machine monitoring is. With Tulip, it also allows the machine monitoring to happen in a passive state. Operators get nervous when they've got somebody watching them. They don't perform at their normal levels. They're always going to try and perform about 120% in front of an engineer or somebody from outside of their operations. And when you actually have active monitoring, is what I would call somebody on the floor with a stopwatch, it doesn't give you a real insight as to what's happening day to day. Anybody that's actually looked at production flow metrics from a Monday through Friday work week, you can kind of see an almost wave effect from Monday to Wednesday, and then Wednesday and Thursday it peaks, and then Friday it drops off a little bit for those operator efficiencies. Whereas if you have somebody out there with a stopwatch, I can pretty much guarantee you that Monday through Friday that they're out there, it's going to be great. It's going to be awesome. It's not going to be a realistically maintainable output for that operator with the machine while it is running. With Tulip, you're able to actually see in a passive way how the machine is running, the reason codes as to why it goes down, and it gives the operators a chance to actually be able to breathe and focus on their work without needing to worry about somebody standing over their shoulder.
Yeah, Absolutely. Rob, you want to, anything to add there?
No, he's right on the money. It's so well said. I'm just complimenting him. That's great.
Excellent. Yeah. Love the attitude there. But I want to flag that as well, because I think I want to ask one or two more questions on this topic, but I think that's ultimately where this conversation is going, is that machine monitoring is not necessarily reducible to just machines. Like it's not a solution that only counts for machines. Machines are part of broader manufacturing processes, and humans are ultimately part of manufacturing processes. And creating something that actually works for a manufacturer requires accounting for both of those factors, both machines and humans. And there's no way to actually create those really impactful improvements without sort of seeing how all of that fits together. All right, so Ed, Rob, I want to ask you a couple follow-up questions, which is that like Tulip and CPS both work with manufacturers who have different levels of digital sophistication. They're sort of in different stages along the way. What would you, is that a problem? Can machine monitoring fit into someone who's really far along, has been innovating for a while, as well as a manufacturer who just wants to get started?
Oh, absolutely. When, we see all levels of sophistication, from a mom and a pop shop to a $13 billion organization and everything in between. We see companies with hundreds of machines that require monitoring, and then not so many. And very oftentimes they're different kinds of machines, they're different methods of connecting, etc. But CPS specifically has a variety of tools that help our clients connect whatever machine it is to Tulip, as well as to other business systems that they may be using, whether it's an ERP system, an MES system, etc. So just working in close contact with CPS and Tulip, we can pretty much get the job done no matter what kind of environment we're looking at.
Excellent. And would you have any advice for sort of an engineer or manager who wants to get started, but like doesn't necessarily know how to take the first step or what to do?
That's yes. Just call us. Call Tulip, and there's really no time like the present to start monitoring your machines. The data that they are creating is really a treasure trove to greater profits, and really that's what it's all about. We've talked about ROI a little bit with Tulip and machine monitoring. I don't know if it's the right time to talk about it, but we have a really great story on ROI and Tulip. Can I just jump right into that?
Yeah.
Okay, great. So, I'll be quick about this, but great story. We go in, it's a fairly large company. I can't really talk about it much more than that, but they're interested in machine monitoring, and we say, how much are your machines running? How much uptime are you seeing? And they give us for instance, they look over at some machines, basically 6 machines, and say they're up probably 80% of the time. And we're like, oh, okay, that's really good. So we put in Tulip a POC, a proof of concept, and they discover it's only 50% of the time. So they're shocked, but we're like, don't worry, we'll put in some process improvements, things like notification that the machine is down, etc. And we are able to actually increase the machine uptime from 50% to 65%. And that's fairly astonishing in and of itself. But then when we measured and extrapolated based on the 6 machines that we did, determining each that these machines can produce 200, 600, 2,000 parts an hour or so, we calculated the net profit, with their help, of course, just on those machines with a greater uptime per part. They were going to add roughly 500,000 annually. And we built that out to the additional 55 machines that they were looking at, which was upwards of 5 million or so in additional profit a year. And that was at just one of the 6 facilities that they have. They have somewhere upwards of 200 machines in some of those facilities. So it's very impressive. And so when I say there's really no time like the present, I think that kind of sums it up pretty well.
Yeah, I don't know if there's any additional comment needed on top of that. Like, they paid off their investment in Tulip very quickly. We can say that.
Exactly.
For sure.
Absolutely.
Excellent. Well, thanks for sharing that. That's fantastic.
Yep.
So at this point, I want to go back to the topic that Chris broached, which is that machine monitoring in some ways, as much as it's about machines, is also a fundamentally human initiative. It's about putting machines and humans in a broader context of industrial processes. So at this point, let's start talking about why that's the case. So one phrase that often comes up in this sort of human-centric machine monitoring solutions conversations is OPE, or overall process effectiveness. Dylan, do you want to sort of give a definition what that means?
Yeah, so a lot of people talk about machine monitoring, they talk about OEE. We try to think of Tulip as like a more human-centered company about OPE. So it's not just your machine, it's the person loading it, it's the supplier delivering the raw material, it's the assembly line afterwards, and it's the QA line. You really need this holistic view of your entire process to really understand how efficient you are. The machines are just one part of that. So we like to think about, recording data and OPE. And so OEE is a great place to start with your machines, but then as you expand Tulip to, material handling and final assembly and QA, you get to actually see the life cycle of that part going through your entire facility. And then you can get OPE, which we think is the much more valuable analytic.
Excellent. Chris, do you have anything to add there?
Well, I thoroughly agree that overall process efficiency is the metric that's being measured in current iterations in shop floor manufacturing, because the human worker, even when you have robotic cells, you're still having human workers maintain and monitor those cells to be able to make sure that they're catching any time, any alarm outs, to get that machinery back up and running as fast as humanly possible. I kind of look at the operators, I guess, would be, not to be too NASCAR, but they're your race team drivers. They're the ones on the floor. They're the ones on the track. They're seeing everything that's going on with the machine. They're the ones that are communicating with their supervisors, who I like to call the pit chiefs, when they need to refuel, like restock supplies, restock coolant, if they need tooling change, changing their tires, if they're having any issues with the machine or the process at that point in time. Without machine monitoring augmenting that experience, it takes a long time to learn those machines. Machine monitoring shortens the onboarding time for newer operators and allows your Class A drivers, your top guys, to get back to being able to run their machines more efficiently, because the machine monitoring is helping those newer operators, as well as the experienced operators, be more efficient in their day-to-day operations.
Excellent. Yeah, I mean, there was so much you just mentioned there, which is that, I mean, humans are interfacing with these machines constantly. Like, as much as the machines are what's producing the parts, humans are the ones doing the setup and communicating when things go wrong. And the way you just spoke about it, it makes it seem like machine monitoring is as good for like fostering a culture of communication and fostering as much transfer of information as possible as it is for just giving you visibility in the first place.
Yeah, it also turns around and it removes a failure mode in that type of communication. When you're using machine monitoring augmented by operators interface, I don't know if you've ever seen old part reports or shift reports. I myself cannot print anything smaller than what I did when I was in the first grade on the double wide print paper. My cursive is beautiful, but I can't print that well. I'm not sure if you've ever seen a coffee ring stain on a piece of paper.
Sure.
In manually driven processes, that paperwork, that data is then recorded by the operator, then handed off to a process engineer. The process engineer then has to rehandle that data, entering it into a spreadsheet. Then an efficiency engineer would have to take that data and then actually run their analytics with it. And that's actually giving them 3 failure modes alone by just having to thrice handle that information. Whereas Tulip turns around, automatically gathers that information, and can disperse it into the analytics automatically. Those failure modes of communication are taken away to where you're actually getting the true data recorded by the operator in a computerized format to where everyone can read it, digest it, and use it as they need to. And that in itself is an ROI that I can personally attest to as being a quality manager in the medical device field for a while. That is a boom.
Absolutely. And on the work instruction side, we talk about in a similar way, if you have, an SOP for loading a machine and you change that SOP, you have to then, if you're printing those on paper, even like laminating them, you have to go make sure you remove all of the old ones before you put the new ones down. And I've seen in many instances where you see 4 or 5 different revisions spanning a year or so throughout the factory for the exact same job. So you don't even know if they're doing them the same way. That all leads into OP, changes in efficiency. So being able to version, Tulip applications that are, focused on these kind of machine-focused jobs and only allow the newest version to run and, change all those things simultaneously also reduces that.
Right. From an efficiency standpoint, but also from a compliance standpoint of having
that's a good point.
for manufacturers in regulated industries, like being assured that you will only have the newest version that you need to maintain compliance running at any given time. So you mentioned something, both of you actually mentioned something in there that I want to follow up on, which is that machine monitoring applications are also often combined with other kinds of applications like work instructions or changeovers or quality. Would one of you like to speak to sort of ways you've seen different kinds of manufacturing applications combined with machine monitoring? Or Chris, would you like taking it first?
Yeah, one of the previous points I brought up before was those downtime reason codes. There's also when the machine goes ready for, say it's a spool wire machine, and it gets ready for changeover. The end of the spool runs out, it trips the low limit sensor. The work instruction can also turn around, and on the HMI screen, the work instruction will be automatically triggered to go to a video showing that operator how to load the next wire spool and giving them directions to run their barcode scanner for traceability against the material that they're putting in. And then that's all recorded right then, right there, real time. As many auditors will tell you, the number one finding when going in and auditing any process is good documentation practices. What it takes is one area where they forgot to initial, if it's asking for a quantity and they didn't even put a slash mark there. Those are all findings inside of controlled regulated industries. The beauty of Tulip is that when they barcode scan, it grabs that material lot, it automatically puts it into the completions that can be pulled for the analytics and traceability at any point in time after that action has occurred. There's never a time where there's a missing sign off. There's never a time where they forgot to fill out a form, or a form gets blown away by the wind, or somebody spills some coffee on it and they forgot to make another photocopy. And as we had spoken about earlier, the validation and verification and knowing that you're always working with the most current, approved, updated process on the floor makes it that much easier for the operators to have repeatable wins every day.
Yeah, again, I find myself pulling so many things out of each of these responses, which is you have the validation and verification, which is, I think, ROI in and of itself. But one thing that came up in your response as well is visibility, in that you see exactly how humans are interfacing with these machines. Like you're seeing exactly who performed which changeovers, how long it took, and then what the results were afterwards. So you can start to have all of this different quality information and all of this process time and cycle time information that you would normally attribute just to a machine process actually reflect back on the humans who are interacting with them.
Yeah, it gives great insight also for when it gives the operators a chance to be able to showcase and shine. It also gives the supervisors the ability to have insight to where if a particular operator might need a little bit more retraining, or they might need to modify a process to make it more effective and efficient for that shift or that particular person. We've had a couple of instances where it might sound funny, but some operators are colorblind. And
Sure. Yeah. It's a thing that happens, yeah.
yeah, well, it just being able to turn around, and since Tulip is an electronic platform, we can have those directions come up in any color. And having those video instructions, especially taking input from the operators on the floor, the old timers, the guys that have been there that know these processes in and out.
Yeah.
Feedback process is also them recording that oral tradition that was such a part of manufacturing for the past century and a half, because in another 10 to 15 years, all of that oral tradition is going to be retired. And now they're able to actually put it into an electronic format for the next generation of manufacturers to be able to benefit from those types of instructions. Do that in written instructions, JPEGs, video format, if you want to get fun and make a couple of fun GIFs to go along with it, to really showcase some of the tips and tricks that those guys used to know.
Excellent.
Yeah, that tribal knowledge is extremely important, and finding a place to put it that's a good digital archive is, as you said, extremely important as those people, enter retirement age.
So at this point, we've covered how to get started with machine monitoring, how to bring humans into it, and I think the sort of last set of questions we have is, what does it look like to scale machine monitoring, and what does it look like to prove value and iterate on top of your program? So Rob, I know your story earlier about the manufacturer who found that their uptime was significantly lower than they thought was a good introduction to this. Do you want to continue to say a little bit more about how easy machine monitoring is to scale?
Sure. The beauty of Tulip is that no-code built apps are easily tweaked to capture a particular machine's KPIs, and we've touched on this, in various aspects of this discussion. If we're talking about a fleet of machines of the same type, it's as simple as copying and pasting after the software has been connected. And conversely, if it's a variety of production machinery, the ease of copying and changing just a few key parts of an application is easy and controlled to ensure validation and verification, essentially for all of the manufacturing operations. So, just working closely with Chris and myself, we can get that scaled fairly quickly.
Excellent. So I think the sort of conversation of scale is sort of predicated on having proved value. So with machine monitoring, how do you prove value? What does ROI look like, Rob?
I would say the first ROI is insight. Seeing the uptime of a machine process allows operations to review what they're quoting versus what the real output is. So, for instance, most shops we see go from a push schedule to a pull schedule in a very short time after full implementation. Defects due to machine malfunction are captured much sooner, and they can be reacted to, allowing for a much lower scrap rate. And we're seeing better times on delivery rates, higher quality, lower downtime on the floor. All of this leads to better throughput, and they're all easy to quantify in real numbers, and of course in real time. So we see folks, just reaping the benefits of almost instantaneous ROI. It's just, frankly, it's just obvious.
Well, I mean that's fantastic, because a lot of what we hear is that there need to be sort of hard cost savings in addition to the data, and it sounds like it's really simple to prove hard cost savings in this case.
Yeah, because you have all that data.
Excellent. So, Kristen, I know when manufacturers start to get more mature with their machine monitoring processes, they want to add nuance to their applications and they want to iterate. What are some directions manufacturers can take machine monitoring once it's off the ground?
Well, I mean, with manufacturing, there isn't a cookie cutter approach. I mean, that was one of the larger failures of early ERP systems, is that one size fits all. With Tulip, different operations can have natural easily incorporated into the current rollout. I mean, considerations, we've incorporated everything from quality assurance to maintenance protocols, in process and end process inspection, real-time updates from the shop floor to warehousing and vice versa. And the real key factor is determining what KPIs a company is looking for to improve on next. I mean, it's when we give them their first set, when we develop those ROIs from the key performance indicators in our first sessions with them, we're really and truly able to turn around and take a look at what those outputs were and where the next best place to do the rollouts and implementations would be for their operations, give them the value-added strength that Tulip brings to the table.
Well, I think what you're describing right now is sort of one of the most compelling reasons to work with someone like CPS up front, which is that the entire lifespan of the project is dependent on how well you frame it at the beginning and whether or not you're selecting a use case and sort of isolating the KPIs that matter to you from the beginning.
Yeah, I mean, it makes it very interesting when in as short a time as 5 years ago, if you saw a 5% improvement on your throughput on floor operations, that was a bonus and a victory. In today's IoT augmented states for manufacturing operations and what Tulip has already brought and is continuing to improve upon and expand upon, throughput improvements of 10 to 15% in one business quarter are not outside of the realm of possibility. That's not pie in the sky. I'm selling you snake oil types of numbers. Those are outputs that we've seen consistently from customer implementations from the first iteration, version 1 to version 1.5 to version 2.0. And the beauty of it is that pretty much from the initial rollout, the company's own internal teams are getting real-time experience in how to build those apps and how they can better tailor suit it to their operations to where they are able to utilize Tulip on their own and be able to improve their operations incrementally with really impressive outputs.
Yeah, I wish you should work in marketing for us, because that's sort of the mission statement, which is just manufacturers can take control of their processes and their data. They can iterate on it. Like I think that's correct and really well expressed. So thank you.
Like I said, this is something that we've seen consistently from customers where we've done Tulip deployments. And Clear Process Solutions is all about the digital transformation and making that type of throughput increase happen. It shouldn't be a pain point. It shouldn't be a mystery black hole where we're going to throw money at this type of solution or this type of solution. Data-driven process improvements are key to business operations being able to maintain their current customer base, grow their customer base, and improve operations for themselves today, tomorrow, and 20 years from now.
Excellent. So with that, I think that about exhausts this topic of conversation. I want to say a very, very big thank you to Chris and Rob for joining us. Chris and Rob, thank you so much for joining us.
Thanks so much.
No, thank you guys for having us.
Our pleasure.
And Dylan, thanks for joining us as well.
Always a pleasure.
Our contact info will all be in the final slide here. If you have any questions at any point, reach out to any of us. We always answer questions as soon as we can. Thank you all. It's been a pleasure. Have a great rest of the day.
Thanks.
Bye.
Bye.
You guys have a good one.